Hello everyone and welcome to this lecture. In this lecture, we are going to cover the regression metrics and KPIs. So let's get started. All right. So if you guys remember from the previous lecture, is that in order to develop a regression-based model, we wanted to develop a relationship between two variables. That's in case of a simple linear regression, or for more than two variables, and that's what we call it multiple linear regression. Pretty simple and straightforward. So let's assume that we have a simple linear regression case, and here we have the age, which is not in number of years, of the applicant. Here we have the insurance cost, and we went right there, we plot all the data points that we have, and then we try to obtain a straight line, which is my straight line here, that can best fit our training data, okay? So the question is, how can I know if this straight line is good or not, okay? So to do that, what we do is that we try to calculate what we call it the residuals or the error. So simply put, we calculate the difference, the vertical distance between each of these points, each of these data points, and these are coming from the training data, and from my model, from my best fit model, supposedly, okay? So what we do is that we, again, draw a vertical lines between the points and between my best fit model, and then that's what we call the error. And what we do is that we subtract this distance, these 2 points, the distance between the 2 points. Simply, we calculate what we call it the residual or the error, which is simply my yi actual. These are the actual data points. These are the points that lie on the straight line here are coming from the model, right? So these are the predicted, or what we call it the estimated values. And that's why we call it y hat, indicating that it's an estimate, okay? So basically we calculate this distance, and this distance will simply be my error. And that's what we call it the residuals, okay? So we calculate the residual for the first point, the residual for the second point, residual here. Here we don't have any residual because basically the point lies on the line. Here we don't have as well any residuals. So now I basically have 3 errors, 1, 2, and 3, okay? And now I want to see, okay, is my model good or not? Does it provide a good fit or not, okay? So let's see how can we do that. So first, we look at the first metric, which is what we call it mean absolute error, or MAE for short. So mean absolute error is obtained by calculating the absolute difference between the model predictions and the true actual values, okay? Simply put, if we take a look at the equation, we get the distances, which is yi minus yi hat, and then we obtain the absolute value, okay? And that's why we call it mean absolute error. So this is my error. We absolute that. So when we absolute it, then we get rid of the sign. So it doesn't matter if that point is up or down, is above my model, above my straight line, or below it. Because again, I'm getting the absolute value. And what we do afterwards is that we sum all that error up. So we actually go here, we calculate the error, we absolute that, and then we sum them all up, okay? And then we obtain the average, okay? And that's or the mean, and that's why it's called mean absolute error, or MAE for short. Again, very simple, very straightforward. So we sum them up, all the error, and we divide by n, which is the total number of points or samples. So MAE is a measure of the average magnitude of the error generated by the regression model. And here's the equation, very simple. And MAE is calculated as follows. First, we calculate the residuals of every data point. Second, we calculate the absolute value of that. So simply we get rid of the sign. And third, we calculate the average of all the residuals. Simply put, if MAE is 0, that indicates that my model is perfect. The predictions of the model are great, and we're good to go, okay? Obviously, I'm gonna show you guys when we deal with real world data, we generally don't get MAE of 0, even if you have the best model. But again, I'm gonna show you guys, in addition to this metric, along with other metrics, then we can see if that model is good or not. If it generates maybe like 80%, 90%, for example, mean absolute error, And I'm going to show you as well other metrics such as R square, adjusted R square. Then we can kind of, like guess if that model is good to be deployed in production or not. Okay. So that's the first metric, which is mean absolute error. The second metric is mean square error, or MSE. Mean square error is very similar to the mean absolute error, but instead of using absolute values, we simply square the difference between the model predictions and the training data, which is my true values. Okay. So MSE is generally larger compared to the MAE, or mean absolute error. Simply put, because we square the residuals. So if you guys see here, we get the error, which is the residuals, which is yi minus yi hat, which is my predictions, exactly the same as before. But instead of obtaining the absolute value for the MAE, we go here and we square that up. So when we square it, then you are basically magnifying the error. You are increasing the error. And you are getting rid of the sign too. Okay, so it's pretty much the same as the residual, as the absolute value here. So what we do here, once we do that, is that for MSE, you will find that if you have a lot of outliers, if you have data outliers, you will find that MSE will become much larger compared to MAE. And generally put, you will find that MSE is generally larger than MAE. But if you have, again, outliers, because of these outliers will have large values or large errors, and you take the error and then you square it up. So when you square it, then that means the MSE will become much, much larger compared to MAE. And simply put, the error in the MSE increases in a quadratic fashion. However, for MAE, it increases in a proportional fashion. Okay. So in MSE, since the error is being squared, any prediction error is being heavily penalized. So if you have a large error, then you will penalize it a lot more. Okay. And I'm going to show you guys as well, when we go to our Jupyter notebook, how can we calculate all these parameters. Very simple and very straightforward. So MSE is calculated as follows. First, we calculate the residuals. Second, we square them up. And third, we calculate the average of the results from step number 2. That's all what it is. Okay. The third metric is my root mean square error. Simply put, we take our mean squared error, which is what we had before, we get the square root of it. That's all what it is. So again, here we have the MSE, we square root that, will generate the RMSE. So root mean square error represents the standard deviation of the residuals, which is simply the dispersion away from the mean. Okay. So that's the RMSE, and RMSE can be easily interpreted compared to MSE because RMSE units match the units of the output. This is actually very important, and actually when I take a look at any model, I tend to look at the RMSE because, for example, if we are trying to predict, let's say, the salary, for example, of an employee, you will find that the units of the root mean square error is actually in salary units. It's in dollars. Okay. So it's going to give you a sense of how off you are. Like what's the error, basically, because it's the error is exactly the same as the units of the output of the actual predictions coming from my model. Okay. So, however, for MSE, for the previous metric, because we square it up, the units will be very different. Okay. But here we actually square it up, but then we obtain the square root. So the units will go back to my original units of my output. So the RMSE is calculated as follows. First, we calculate the residuals for every data point. Second, we calculate the squared value of the residuals. Third, we calculate the average of the squared. And then fourth, we obtain the square root of the results. And that's it. Very simple. All right, let's keep going. So we have the mean absolute percentage error, or MAPE. Simply put, if you guys remember MAE before, which is the mean absolute error values, could range between 0 and infinity. So it can take any number, basically. So it's really hard to interpret the values. However, for the mean absolute percentage error, or MAPE, is actually equivalent to MAE, which is what we covered before. But because we present the value in a percentage format, so you can actually interpret, you can actually understand the data. So now you can see, okay, I know my error is like 5% or maybe like 7% and so on. How do we calculate that? Very simple. We calculate the residuals. which is yi minus yi hat, and then we divide by yi, we obtain the absolute value, and then we sum that up, and then we obtain the average, we divide by n, and then we multiply by 100%, so now we obtain that in a percentage format. So MAPE might exhibit some limitations if the data point value is 0, because again, since you are dividing here by yi, you have to make sure that you are not dividing by 0, because that again will mess up the calculation for us. So that's all what we have for MAPE, okay? All right, the next metric is mean percentage error, or MPE. So MPE is similar to MAPE, but without the absolute operation. So basically here, we just got rid of the absolute operation, okay? All right, MPE is useful to kind of give you an insight. How many data points do I have in the positive and in the negative? So now I know like how many, like basically positive errors or negative errors. If I have data points above my predictions, or above my model, or above my straight line, or if we have data points below the line, because now again, I'm not squaring it up, or I'm not obtaining the absolute. So here the sign will make a difference, okay? So that's basically what we call it MPE, or mean percentage error, okay? All right, so that's all what I have for this lecture. I hope you guys enjoyed it. In the next lecture, we're gonna keep going with the rest of the metrics, and then we're gonna cover R-square, or coefficient of determination. Please stay tuned, and please enjoy AWS SageMaker practical course, and I will see you guys in the next lecture.